Yes.
My slide is visible.
Yes, sir.
Okay. So, dear participant, good evening. Good evening to all of you. Today I will speak about parametric test in SPSS. So before going to the SPSS problem, let us um, read or gather some basic knowledge that must be required for uh, to use any kind of statistical techniques, or rather say parametric testing procedure in SPSS. We have to have some knowledge of parametric tests. What are the parametric tests actually? How we can use and where and why we should use this kind of testing procedure. Let's begin. So before going to the parametric test, let us check what is hypothesis testing. It is a procedure to evaluate hypothesis about population parameters based on sample statistics. Actually, it means the testing procedure which I use in statistics are in general used in sample, not in the population, because depending upon that sample, we have to draw conclusion about the population and whether that our conclusion is statistically significant or not. We can take the help of some testing procedures. There are generally two types of testing procedure. One is called parametric and the other one is called non-parametric testing procedure. So first of all, we have to know about the word hypothesis. In general, hypothesis means a general statement about the population. A general statement, for example, right now, in my district, in my place, it is raining. Okay, so my statement about these days, or say this month, is that it is a rainy season. It is a rainy month. So this is a hypothesis. Anything or any statement about the population is called hypothesis. Under hypothesis, there are two categories. One is called null hypothesis and the other one is called alternate hypothesis. Alternate hypothesis is the opposite of null hypothesis.
Sir,
Null
to
hypothesis.
disturb you, sir,
Yes.
giving your presentation is not visible.
Okay, let's check.
Yes, only death. Desktop is.
Actually, at the beginning, I actually asked that question whether it is visible or not. Is it visible right now?
Yes, sir. Yes, sir. Right now.
Are you seeing the slides? Some important terms in hypothesis
So now
testing?
we can see the slides.
Yes. Yeah, definitely. Thank you.
Yes, sir.
So under null hypothesis, under the hypothesis, there are two types of hypothesis or two categories of hypothesis we generally found. One is called null hypothesis and the second one is called alternative hypothesis. Okay. Alternative hypothesis is a hypothesis which is completely opposite to the null hypothesis. Now we see what is null hypothesis. Null hypothesis is a statement of equality. For example, if we say there is no difference in the mean systolic blood pressure level of male and female, this is a null hypothesis. Means there is no difference. There is no difference with the original hypothesis. So it is called null hypothesis. Again, another example is there is no relationship between obesity and hypertension. If we have a question to check whether obesity and hypertension, is there any association between hypertension and obesity exists? Okay, then the null hypothesis is there is no relationship between, there is no association between obesity and hypertension. That is the case of association. If our research question would be like, Is there any relationship between obesity and hypertension? Then our null hypothesis will be there is no relationship between obesity and hypertension. In this way, we have to construct the null hypothesis. Okay, but the alternative hypothesis is what? It is completely different from null hypothesis. So we generally say it is the opposite of the null hypothesis. For example, in the first example, we have seen that the null hypothesis is there is no difference in the mean systolic blood pressure level of male and female. In this case, the alternative hypothesis will be there is some difference in the mean systolic blood pressure level of male and female. In the second example, there is no relationship between obesity and hypertension. This is null hypothesis. Now, my alternative hypothesis will be there is some relationship exist, or there may be some relationship exist between obesity and hypertension. And this is the concept of p-value. Okay. Initially, in the earlier times, we generally calculate the test statistic, or say the mathematical formula for each testing procedure, and then compare that value with some standard tabulated value. But nowadays, instead of using that standard value, we generally take help of p-value, and this is the concept of p-value. The right part is showing here in the slide. It is the p-value. That is the probability value of getting that point. Next, this is the steps that are involved in testing of significance, or say drawing inference of a sample for the population. Step 1, we have to state the null hypothesis. In step 2, we have to state again alternative hypothesis. Sometimes it is omitted. Step 3, state the level of significance. Here the level of significance means how much you are confident about your result. In general, it is taken as 95% confidence, which means the standard p-value is 0.05, means 5% level of significance. In general, it is like if you have if you are going to purchase apple from the market, and you find that in a bucket of 100 apple, there are 5 that type of apple which are not fit for use or fit for eat. So out of 100, you are finding only 95 apple are fit for eating or fit for use. Okay, so this is called level of significance. Okay? In other words, how much you are confident about your conclusion or about your interpretation. This is called level of significance. Then, of course, you have to have some data. It may be primary or secondary, where you will use the test statistic. Step 5, use proper statistical test and calculate the test statistic. Test statistic means the in general, for you, it is easy to understand. Like it is some kind of mathematical formula. Okay, depending upon the testing procedure, you have to put the data on the table form, and then from the table you have to calculate the mathematical formula for each statistical testing procedure. Okay, but these are some manual steps, but in SPSS we won't follow these kind of things, because instead of making table or some kind of calculation, SPSS do these things by itself. Okay, then after getting the calculating result, we have to compare with initially, as I told you, we have to compare it with the p-value, and we have to draw conclusion or inference about the sample. So I'm showing some diagrammatic representation. So testing of significance or testing of hypothesis can have 6 different category or different steps, or say different branch. Actually, not actually branch. There are 6 different parameters that maybe have in a testing of significance or testing of hypothesis procedures. First, you have to setting up the hypothesis. It may be there two hypotheses are there. Now, one is null hypothesis, and the second one is alternative hypothesis. Then types of test. One is called one-tail test, and the other one is called two-tail test. Errors. One is called type 1 error. One is called type 2 error. And level of significance, maximum chance of making type 1 error. Select the proper test statistics, whether F test should be used in your data set, whether Z is applicable, whether T test is applicable in your data. Depending upon your research question, as you have collected data, you have to collect data, and depending upon your problem, you have to draw conclusion, right? So you have to choose the proper testing procedure so that you can get your desired conclusion. Okay, then chi-square test and ANOVA, and decision made on the analysis whether you are accepting the null hypothesis or rejecting the null hypothesis. As I have told, the statistical test can be divided into two different categories. One is called parametric test, and the second one is called non-parametric test. This is definition of parametric and non-parametric. In general, you just remember that T test, X test, F test, chi-square test are generally known as parametric test because some assumptions are there that to be fulfilled before using this type of testing procedure. Okay, like your distribution, your data should be drawn from a population whose distribution should be normal. Okay. Again, this kind of assumptions are not needed in case of non-parametric testing procedure. See, for parametric test, first you have to check whether your data follows normal distribution or not. If your data follows normal distribution, if your data set is under normal distribution, then only you can use parametric testing procedure. On the other hand, otherwise you can't use parametric testing procedure. But in case of non-parametric test, you don't have to check the normality assumptions at the beginning. Okay, so I generally prefer to use parametric test because in that case, one step is smaller for me, or without checking the normality, I am directly using the testing procedure. And there are many more non-parametric tests are there, like parametric test, but advantage is that you don't have to check the normality of the normality that may or may not be lies in the data set. Again, I am repeating the point. Before using any kind of parametric testing procedure, you have to check the normality assumptions, whether the data follows normal distribution or not. First, normality test. If normal distribution, if the data follows normal distribution, then only you can use parametric test. But what happens when the data doesn't follow normal distribution? Then again, you have to go through with the non-parametric test. But in case of non-parametric test, without checking that normality assumption, you directly use that non-parametric test, which means if a dataset follows normal distribution, then also you can use non-parametric test. If the dataset is not followed normal distribution, then also you can use non-parametric test. But in case of parametric test, the dataset must follow normal distribution. So these are the testing procedure or plots to check whether your dataset follows normal distribution or not. First one is histogram, box plot, QQ plot, and then one test is here mentioned, that is known as Kolmogorov spin-off, or in short abbreviation, it is known as KS test. So are you seeing the graph? Have you able to do? Yeah. The first one is histogram assessing normality. In the first two graph, it is a plot of histogram, and you see the curve in the second graph is showing a graph which is something look like a bell shape. Generally, we say that normal distribution curve is a bell shape. Okay. Again, the below two graph, below two plot are known as skewed distribution. The left left bottom graph is known as positively skewed, and the right button is known as negatively skewed. These are some way to check whether your data follows normal distribution or not. And this is the block box plot, again type with the help of which you can check the normality. And this is known as QQ and normal QQ plot or PP plot also. So if you are seeing that some dots are there with a blue straight line, if the data lies like that, means the dotted point are lies in the line, in the straight line, then it is taken as the data follows normal distribution. On the other hand, in second curve, if you see the dotted plot, dots are above the straight line. If the dot lies in the straight line, then it is known that the data follows normal distribution. On the other hand, if the dot or the points are lies outside the straight line, means it maybe in the upper part, maybe in the lower part of the straight line, or maybe upper and lower in both part, then it is taken like the data doesn't follow normal distribution. So in the testing procedure, Kolmogov spin-off, it was named after Russian mathematician Andrei Kolmogov and Nikolai Spinov. Okay. Here the null hypothesis is the data follows normal distribution. Okay. And the alternative hypothesis is the data doesn't follow normal distribution. And decision rules reject the null hypothesis if the p-value is less than equal to 0.5 and accept the null hypothesis if your p-value is greater than 0.05. And then this decision rule is applicable for each test. Okay, this is not only used for KS test, it is used for all tests. In when I'm showing you the SPSS way how to do it, then you will see that this decision rule will be followed by each and every testing procedure. Okay. Then these are the parametric tests which generally use an SPSS, one sample t-test, or it is also known as single sample t-test, then independent sample t-test, or sometimes it is known as two sample t-test, then dependent or paired t-test, and then one-way analysis of ANOVA. Okay. So before going to any kind of statistical testing procedure, you just have to have some knowledge where you can use this kind of test. First of all, you have to know whether you are going to use parametric or non-parametric, and then depending upon the sample size, you have to select which test is proper or applicable for your data set. If here then sample size is denoted by n, sample size means if I need the height of the students of this class, means I think approximately 32 participants are registered for this program, and say this is the size of the population. Okay, for this workshop, the size of the population is 32. Now I need the average height of the student. Instead of doing analysis, or instead of collecting data of each and every 32 students, if I prefer to have data for 10 students from these 32, then that 10 will be known as sample. Probably you know about that. That value 10 is known as size of the sample. Here it is denoted by n. And if the sample size is greater than 30, means small n is greater than 30, then it is known as large sample. And if small as n is less than equal to 30, then it is known as small sample. Then the next thing you have to know, degrees of freedom. Phrase degrees of freedom or the term freedom means freedom to vary. How much freedom a sample get to vary from each one value to another. As the number of restriction increases, your freedom also decreases by 1. If the size of the sample is n, then you can choose n minus 1 variation freely. This is called degrees of freedom. Now, single sample or one sample t-test. When we can use this kind of testing procedure, I will show you in the example, but before I will discuss how we can use and where we can use. One sample t-test is a statistical procedure used to determine whether a sample of observations could have been generated by a process with a specific mean. If you have some specific mean in advance, then only you can use single sample t-test. The one sample t-test compares the mean of your sample data to a known value, right? Because some specified value, sometimes it is taken as mean, or sometimes by reviewing the previous literature, you have to specify some test value, and your answer will be around that test value, or you have to draw conclusion concentrating on that test value. For example, it is known that mean systolic blood pressure of people residing in a particular geographical area is 118 milligram per AZ. Suppose we draw a random sample of size 300 from the area, and the sample mean systolic blood pressure is found to be 120.42 mmHg. Then what happened? By using single sample t-test, we have to draw conclusion in this case. Now, by using that testing procedure, one can study whether the population mean from where the sample drawn is equal to 118 mmHg or not. See, in this case, what you have got from the earlier research, that mean systolic blood pressure of that area is 118. Okay, but from the data set, when you calculate the mean systolic blood pressure, you found that no, it is not 118, it is 120.42. Now, can you interpret that 120.42 is the mean systolic blood pressure of the population of that area? Because depending upon what we are doing a conclusion. We are drawing inference about the population depending upon the sample. Are you getting my point? You are calculating for 300 people, 300 persons, okay, 300 people, but you have to draw for whole population. You have to draw conclusion for whole population. You are getting 120.42 mmHg systolic blood pressure for 300 person. Okay, but can you draw conclusion that this is the average systolic blood pressure of the population? With this knowledge, we can't. So, to draw statistical conclusion, we have to use t-test. Here, the null hypothesis is the population mean is equal to 118 mmHg, which we have got from the previous literature review or previous analysis or say. The alternative hypothesis is the previous population mean is not equal to 118. Okay. Now, we have to use the t-test, and then we have to draw decision whether our result is that 120.42 mmHg is the population mean, or 118, which we had got in earlier from earlier research, is the average height. And this is for one sample t-test. If we have to draw conclusion by comparing two different types of variable, then it is called two sample t-test. In one sample t-test, we use only one variable. In two sample t-test, instead of using one variable, we use two different samples. For example, if we want to test the equality of means of systolic blood pressure of male and female, okay, whether in this case my research question would be like whether the systolic mean systolic blood pressure of male and female are same. See the null hypothesis. Mean systolic blood SBP of male is equal to mean systolic blood pressure of female. Alternative hypothesis is mean systolic blood pressure of male is not equal to mean systolic blood pressure of female. See the difference. In first case, we have only one variable, or say one sample. In this case, we have two different samples. One is for male, one is for female. Again, dependent sample t-test or pair t-test. This kind of test generally used when you have one sample, but that sample have two data before and after. Say we are using a drug for to control blood pressure level. For example, say there are 20 persons, or say there are 20 hypertensive patients, and a company decide to test their drug on that 20 persons, 20 hypertensive patients. At that time, what the company do, they take the measure of blood pressure, systolic and diastolic, before injecting that drug or before giving that drug, and record that data. Okay, this is one sample. This is sample one. Before injecting or giving that drug, the company recorded systolic and diastolic blood pressure of 20 persons. Then they give that drug to those patients, and after 1 or 2 hours, they check again the blood pressure level. Okay, again they are getting 20 different data for 20 different persons. In the first sample, they are collecting data before giving the drug. In the second sample, they are recording the data after giving the drug. Okay. Here also we have two different samples, sample 1 and sample 2. But the difference is that the patient is same. Right? In two sample test, your first sample and second sample are different. In our previous example, we have taken systolic blood pressure of male and systolic blood pressure of female. Okay, both are different. But in paired t-test case, but in this case, we are entering the drug to the same patient. Only we have 20%. Maybe they are male, maybe they are female. We do not need this. But after getting the drug or before getting that drug are recorded. Now, if we want to check whether the drug have some impact on that patient or not, we have to go through with pair t-test. Okay, here the null hypothesis will be mean blood pressure level, or like systolic blood pressure level before treatment and after treatment. Okay, which is equal. For alternative hypothesis, mean blood pressure level before treatment not equal to mean blood pressure level after treatment. Again, one-way ANOVA. When we do one-way ANOVA, we generally use t-test for only two samples. If we have one sample, we can use two sample t-test. If we have two sample, then also we can use t-test. If we have paired sample, means two sample but in pairs, then also we can use pair t-test. But if we have more than two sample, then we can't use t-test. Instead of t-test, we have to use one-way analysis, one way, or there are another part, two-way analysis of variance. Or so in general, we can say if we have more than two samples to test, we have to use ANOVA. Or in ANOVA or in analysis of variance techniques, we are using F-test. Okay, situation is like the one-way analysis of ANOVA is used to determine whether there is any statistically significant differences between the means of three or more independent groups exist or not. This test is used to compare the means of three or more groups. Okay, if we have two groups, if we have one group, we can use t-test. But if we have more than three or more than three groups, then we can't use t-test. Instead of using t-test, then we have to go with ANOVA. For example, we want to compare the mean blood pressure level of individual with respect to their type of work, having three categories: sedentary, active, and heavy. I'll show you in example in SPSS. Here the hypothesis would be mean blood pressure of all the groups are same. Alternative hypothesis, there are at least two groups having different blood pressure level. And then chi-square test of independence of attributes. There are 3 or 4 chi-square tests are there. One is for attributes, one is for association, one is for test normality test, and then sorry, I forgot the last one. But here we will use only here in SPSS we use chi-square test. I'll show you chi-square test of independence of attributes. The chi-square test of independence of attributes is used to determine if there is a significant relationship between categorical variable exists. If there exists any significant relationship between categorical variable, we have to use chi-square test. The frequency of each category of one categorical variable is compared across the category of second variable. When we are we'll do the SPSS, I'll show you how we can interpret and how we can do chi-square and where we can do chi-square test. Okay, for example, we want to study the relationship between hypertension and family history. Family history means whether your family, any of your family member have hypertension or not. Sometimes it is usually it is usually come to hear that if your mother, if your parents, if your any family member have hypertension, then yes, you may have that that disease. Maybe here, maybe now, maybe in near future. Because means if your parents have, or if you have any family members from your any members from your family have hypertension, then there is a probability of having that disease in near future. Or okay, it is like there is some possibility, and we want to study whether the occurrence of hypertension is more among those who have family history of hypertension. Here the hypothesis is there is no relationship between family history and hypertension, and for alternative hypothesis is like there exists a relationship between family history and hypertension. I once again want to show you that alternative hypothesis is the opposite of the null hypothesis. So there are some situations are given where we can use this kind of testing procedure.
So I have a question.
Yeah, definitely you
Sorry
can
to.
ask.
Yeah, so in the chi-square test of independence of attributes, there
Yes.
should be only two categorical variables, right, sir?
No, it is not necessary.
There can be more than two, sir?
Yeah, definitely. See, if there are two variable and each variable have two categories, then there will be a 2 by 2 table. I'll show you. Okay, there will be 2
Okay,
by
sir.
2 table, and that table is known as contingency table. 2 by 2 contingency table. Okay, it is look like a matrix, 2 by 2 matrix,
Yes, sir.
but it is not necessary to have only two categories. Okay,
Okay.
there are,
So basically, sir, there can be more than two variables.
yeah, more than two variable, more than two categories, and each variable can be all can also be happen. 3 by 3 contingency tables are there, 4 by 4 contingency tables are there. It is not
Okay, sir.
necessary to have only two categories, but yes, with one category you can't do chi-square analysis. You have to have two or more categories.
Okay, okay, sir.
Okay, fine. Any other
Sir, is it a non-parametric test?
chi-square,
Is it a non-parametric test?
chi-square or any other thing?
Try first, sir. Try first.
So there are two types of chi-square test.
Yeah, sir.
Okay, you get chi-square non-parametric distribution also.
Okay, okay.
So these are some situation. Any other question? Okay, definitely you can ask any question at any point of time. It is not necessary to ask question at the end of the class, because whenever right now the two participants have asked the question, it will be clear for you also that in between my presentation you can ask at each and every point, or wherever you feel it is necessary. Okay, no problem for that. Any question till now from any other participant? See, why I am showing you these theoretical things, because you can learn SPSS by seeing the YouTube also, right? But and if you input or make a database in SPSS, by clicking the options, you will get the result. But the main thing is the interpretation or drawing the inference. You will be able to draw inference only when you will have the basic knowledge of the statistics of or that testing procedure. Otherwise, you won't be able to do so, because this is a computer, this is a laptop. You are entering data. It needs only it convert those data to 0 1 binary. You already know about that. And by clicking any options in the SPSS software, you will get some kind of value. But the main thing is that what is your research question? Is that testing procedure is applicable? Is that testing procedure is right testing test for your data? Is that testing will give you right conclusion or desired conclusion for your data set or for your research question? This question can be answered only when you have some a minimum basic knowledge of statistics. Otherwise, you will learn SPSS through YouTube also. Consider a situation when null hypothesis, the mean score of student is in a test is 60. An alternative hypothesis, the mean score of student in the test is not 60. Okay, mean score of students in a test means there is one sample. So here in that case, we can use one sample t-test. Again, consider the situation when the mean score of student is a test is 60. The mean score of student in the test is less than 60. Here, the alternative hypothesis is one-sided, and so it is called one-tail test or one-sided test. In the previous example, the mean score of student is not equal to 60, maybe greater or maybe less than. So it is called as two-tail test. But in the second example, it is clearly written that test is and the score test is less than 60. If in place of less than 60, If it is right like greater than 60, then also it is called one-sided test. So this is the test statistic for t-test or pair t-test, and this is the test statistic. We statistician referred it as test statistic without using the s in the statistics word. It is known as the testing formula. C. Subject is known as statistics, and if we cut the last s from that word, it is called statistic. Okay, it is the formula through which we are calculating the testing procedure or techniques. These are some example when we have more than 30 sample size, then we have to use z-test, and for less than equal to 30 we can use t-test. Now I directly go to the SPSS. Is it visible?
Yes, sir, it's visible.
Okay. This is a data set which cover 12,313 data point. Each data is collected from one individual. This is the result for first individual. This is the result for second individual, like that. The first variable is location. Location means here whether the person habitat of a rural habitat or urban habitat, age of the respondent, gender of the respondent, education qualification. I think in the previous classes of this workshop, you have acquired the knowledge of how to construct database in SPSS. So I want to go through this. This is the type of work he or she are doing. There are three options: sedentary, active, and heavy work. Extra salt means whether the person consume extra salt, or there are two options, yes and no. Extra salt means sometimes a person have some intention or like to use extra salt while eating something. Okay, and this is not needed actually. And then height of the respondent, weight of the respondent, mean systolic blood pressure. There are two types of blood pressure generally a person have. One is called systolic blood pressure, and the other one is called diastolic blood pressure. If you have any kind of any one of your family members suffering from hypertension or any kind of blood pressure related problem, then you probably know about that. There are two types of blood pressure. One is called systolic blood pressure, which is measured in the upper level of the scale, and diastolic blood pressure, which is read at the lower level of the scale. Okay. Then the last one is hypertension, whether a person have hypertension or not. This is an example. I just want to briefly want to say that hypertension is what if a person have systolic blood pressure more than 140 and diastolic blood pressure more than 90, then a person is said to be a hypertensive patient. Okay. Now, first we will see how to do parametric testing procedure in SPSS. For any kind of analysis, we have only one option, that is analyze. Go to the analyze button, then compare means, then one sample t-test. Go to the analyze, click on the compare means, then one sample t-test. Click on that. Say I want to check the age. Oh, sorry. I want to check the mean systolic blood pressure, whether there is any change in mean systolic blood pressure or not. Initially, I have told you that for doing one sample t-test, we have to have some knowledge or previous knowledge about the average value. This average value here in SPSS is known as test value. Okay. Now, mean systolic blood pressure is if we have systolic blood pressure more than 140, then we say it like hypertensive. There is a range 120 to 139. In medical language, if a person have 120 to 139 systolic blood pressure, then that person is medically said as pre-hypertensive patient. Okay, means there is some probability of having hypertension in near future. So I took like 119 is the average value. Okay, this is something like an example. Probably there is no relevance in real world maybe, but I'm showing you how to do one sample t-test. So for my case, I took 119 as test value and then paste OK. So this is the output. There are two tables we have got. First table shows there are 12,313 numbers of respondents are available whose mean systolic blood pressure is 119.0861. Standard deviation is this and standard error is this one. Okay, by using one sample t-test, we got p-value is like 0.545, degrees of freedom is 12,312, significant level is 0.586, mean difference, and lower and upper bound is so and so. Now, what are the things you have to see? First of all, this n, what is the value? 12,313. I'm saying what are the things you have if you are doing PhD or if you are doing any kind of research, if you are writing a letter, writing a paper, then also you don't have to write each and everything from the SPSS output. Okay, please write down only those necessary points which are given by the SPSS. Don't put each and every table, each and every column of the table in a dissertation in a paper. Instead of that, you just write a paragraph and give only the necessary data. Here, there are 12,313 respondents are there, okay, whose mean systolic blood pressure is 119.0861. Okay, there is a variance of standard deviation of 17.53094. Okay, this is descriptive statistics which describe your data. Now in statistical testing procedure, you are using one sample t-test where you got 0.545 as a value of t statistic. The value of t statistic is 0.545, where with 12,312 degrees of freedom. Originally, the size of the sample is 12,313 minus 1, so it is 12,312. Then the third column refers as significant two-tailed. I already told you that what is two-tailed and one-tailed. Okay, here my null hypothesis is the mean systolic blood pressure is equal to 119. My alternative hypothesis will be what? Mean systolic blood pressure. It is look like how I can show you. Is it visible?
Yes.
One sample t-test here. H0 is what? Mean SBP is equal to 119. Okay, H0 H1, that is alternative hypothesis, is mean SBP not equal to 119. So here what we get, this is called p-value. Okay, sig means significant. We know it like p-value. Now my p-value is 0.586. 0.586. Remember the decision point. Can you remember the decision point? Already I have told you that if your p-value is less than equal to 0.05, then what? Reject the null hypothesis. Reject the null hypothesis. Or on the other hand, if p-value is greater than 0.05, accept the null hypothesis. Accept the null hypothesis. In our case, in this case, what happened? In this case, what happened? We get p-value as 0.586, which means it is greater than what? It is greater than 0.05. It is greater than 0.05. That means whether we are going to reject or accept the null hypothesis.
Accepted.
Yes, we accept the null hypothesis. We accept the null hypothesis from the point that our p-value is greater than 0.05. And you have to draw a conclusion, right? Like the mean SBP of the sample is 119 mmHg. Okay. Any problem?
No, sir.
Okay. Everyone are getting my point? If anything you have, you can put on the chat box also. Naga Krishna Moiri, can you ask the question directly to me? Okay, fine. Shall we apply for the weighted mean of Likert scale? Yes, there are some confusion about Likert scale actually. Okay, sometimes some people are saying like, yes, we can use t-test in Likert scale because of when t-test Likert scale are constructed initially or proposed initially, that was developed and at that time the proposed scientists told that yes, it is the data which are collected through Likert scale are normally distributed, and since it is normally distributed, then t-test can be used. Okay, so yes, any kind of Likert scale you can use t-test, whether it is weighted or non-weighted. But yes, in Likert scale you can use t-test. But some people says like, no, since it is a number instead of some series or say some numeric, it is some numeric value, right? Likert scale is what, 1 to 10. You have to point, give point from 1 to, in between 1 to 10 or 1 to 5, like, right? But it is not in a series. So sometimes people say like, no, t-test or any kind of parametric test can't be used in Likert scale. There are many more discussion you will find or available in ResearchGate also about the t-test and about parametric use of parametric test in Likert scale. You better you go through this. Okay, so this is an example of one sample t-test. Next, again come to the here. So this is mean systolic blood pressure. Okay, this variable refers to the mean systolic blood pressure, and this is gender. Next, my question will be H naught. My question will be whether there is any mean difference of systolic blood pressure among male and female exist. So my null hypothesis will be mean SBP of male is equal to mean SBP of female. This is independent sample t-test. Independent sample t-test. Independent sample t-test. Now for this, alternative hypothesis is mean SBP of female not equal to mean SBP of female. Male and female is not equal. Now we'll see how to do this. These are my data. This is mean systolic blood pressure, and this is gender. Again, go to analyze, compare means independent sample t-test. Go to the analyze, compare means independent sample t-test. Click on that. What you are going to check? Mean SBP with gender. See, you have two different variables. One is mean systolic blood pressure, one is gender. Okay. Before that, you just see gender or sex is a grouping variable. Why? If we see the group, then yes, I coded female as 1, male as 2. Okay, we have converted the qualitative data to quantitative data by coding 1 for female, 2 for male. So this is a grouping variable. There are two groups, one is for female, one is for male. But mean SBP, there is no values. Means this is a scale variable. Directly we have some scales variable or scale data or some numerical data. But in case of gender, we have qualitative data. We make it as quantitative by coding, and then it is known as grouping variable. Now go to the analyze, compare means independent sample t-test. Click on that. First, input the mean SBP to the test variable, then insert the sex to the grouping variable. After that, you have to define the groups. Again, I am saying insert the mean systolic blood pressure in the test variable and insert the group variable, insert the sex in the group variable. After this session, I will share entire this SPSS file and also Excel file to you so that you can do these things in your home. Okay, then define groups. Here group 1 is taking as 1. Okay, group 2 is 2. Why I use 1 and 2? Because in the values of the variable, we have given 1 code for female, 2 code for male, right? We are using only 2 code, 1 and 2. So why we are giving here group 1 as 1, 2 as 2. Put click continue and then press OK. So again, 2 different tables are coming in the SPSS output. The first one is group statistics. When SPSS tells like group statistics, we statistician tells like descriptive statistics. Okay. So, well, there are 6,606 females in the group of the respondent and 5,707 male persons are there. Okay. And these are the means and standard deviation, standard error, so and so. Now, what we have to see here. Don't consider the first 2 column. Consider the third column. Okay. Is it visible?
Yes, sir.
Okay. Consider the third. Consider from the third column. That is T. Here the value of the T is minus 12.722, whose degrees of freedom is 12.311. Okay. Initially, in the first test, the degrees of freedom was 12,312, but here degrees of freedom is 12,311. Originally, there are 12,313 persons are there. Why we use -2? Because there are 2 samples, so why we might subtract 2 from the original data. Now the p-value is 0.000, which means if you see the highlighted yellow color figure, which means 0.576 e to the power minus 37, it is much more smaller than 0. Instead of in your dissertation or in your paper, instead of writing 0.000 as p-value, just write approximately 0. You may use approximate sign, or other way, you just write approximately 0. Because if you see the highlighted figure, it is not equal to 0. Yes, since we have SPSS consider only 3 decimal point, so it is coming like 0, but it is not rightly equal to 0. So instead of writing 0, you just write approximately equal to 0. So by seeing this significant value, we can conclude that there is some significant difference between male and female respondent about their systolic blood pressure. Then again come to this mean systolic blood pressure of male and mean systolic blood pressure of female is same. It is written where? In the null hypothesis. Since we reject the null hypothesis, why we rejecting the null hypothesis? Why? Because our p-value is less than 0.05, approximately equal to 0, which is less than 0.05, right? So we are rejecting the null hypothesis. Rejecting the null hypothesis means we are accepting the alternative hypothesis. Means mean systolic blood pressure of male is not equal to mean systolic blood pressure of female. And why we are using mean here? Because when we are actually this is a data set from a sample survey where we have collected data for systolic blood pressure and diastolic blood pressure for 3 times, 1 times, 2 times, 3 times, and then average the times. Because whenever you are going to, if you feel something low or something illness was occurred to you in recent times or in your lifetime, whenever you go to a doctor, then the first, whenever you check the first BP, then sometimes it is seen like that your BP is quite high or quite low. This is something like something happened in mental condition by seeing a doctor. And medically, it is known like that. So we generally what we do? We generally take 3 times blood pressure and then average them. So instead of writing systolic blood pressure of male, we just use the word mean. So don't confuse by seeing this mean. Okay, this is the, depending upon the type of the data, we generally do these things. So in this case, we reject the null hypothesis. Why? Because our probability or p-value is less than 0.05, which means we are accepting the null hypothesis. What null hypothesis says? Mean systolic blood pressure is not equal to mean systolic blood pressure of the female respondent. Up to here, any problem, any confusion?
No, sir.
No, sir.
Okay.
Sorry, I have a question. So then the two sample t-test can only be for one variable across two groups, independent groups. So only say mean systolic blood pressure between say men and women. That's what you're saying.
Yeah, I can show you another example also. Because in reality, sometimes it is look like in reality you won't find the variable in one sample. Say, I will show you one example. See, is it visible? Say this is an example. Okay. You have to compare the blood pressure of patient making 3 different drugs. Okay. Say there are 2 different drugs, A and B. 2 different drugs. Okay, there are 2 different drugs. A company want to see whether drug A is have some effect on the patient or drug B have some effect. What will you do then? You are getting the data set like that for drug A and for drug B. Now it is a 2 sample. Now I am saying you have to use 2 sample t-test. How you can do in the SPSS? Can you answer me? Will you put drug A as one variable and drug B as one variable?
No, sir, but I don't know what else to do.
Are you getting my point?
Yeah.
There are 2 drug A and drug B. You have to say whether mean systolic blood pressure of after getting drug A is equal to mean systolic blood pressure after getting drug B. you have to check with the help of independent T sample test. Okay, but see, I will show you. Okay, if we put like if I copy these things and directly put in the SPSS page like that and say this is drug A, drug A, and drug B. Okay. Now this is the systolic blood pressure after getting drug A. This is systolic blood pressure after getting drug B. Can you do independent sample T test here? Just think for a minute. See,
These are the same people who've gotten drug A and same people who've gotten drug B, or different people who've gotten drug A and drug B.
no, different people are getting drug A and drug B.
Somebody else is getting drug.
There are 14 people are there. 7 get
Drug A.
7 got drug A and 7 got drug B. Then what will you do? See, if we follow the same step in independent sample T test, then which will be the test variable, which will be the grouping variable,
Exactly, sir. I don't. Exactly.
right?
Mm-hmm. Okay.
So generally, what happen? Whatever we get from the sample survey or from the primary data, when we are making database, we have to be some careful, like, right? Because from primary data or primary collection of data, we are making a table like that. Okay, a person
sir.
are making a table like drug A, drug B, but in SPSS you can't do analysis like that.
Like
For
this.
this, you have to do something like you have to make one
Okay, sir.
for drug. Instead of drug A, it should be like drug. Okay, or sorry, it will be systolic blood pressure. Systolic blood pressure. Now, next one is drug, and you have to put some level for 1 for drug A,
Okay.
2 for drug B. Now, this is for drug A. It and paste it. Now, see the difference. Originally, there are two variable like this, but for SPSS, we convert them to systolic blood pressure and drug. The thing is same. Same thing is here and there also. But now we can do independent sample T test. SBP here, drug should be measure should be nominal. Grouping variable 1, 2, then continue. Okay, and this will be the result.
Yes, sir. I understand. The point is to find make it into a grouping variable. I understand, sir. Okay.
Yes,
Okay, sir.
because
you.
whatever you are getting from the primary data, not necessarily you will get the result from the SPSS in that way.
Yes, sir. Yes, I
You
understand.
have to use your own knowledge how to make database in SPSS so that you can get your reliable or the result which you are expecting.
Okay, sir. Thank you, sir.
Okay, fine. Anything else?
So I have a question. I don't know how relevant is this. Like you had given us initially when we were doing this that for large samples it is the Z test when it's more than 30, and for small samples it is the T test. So sir, over here in all the outputs that are being generated, it is
Mhm.
written T test. So sir, are these the same as in what you had made us write and what this is this the same, or was that for a different
Yes,
purpose?
initially I have told you that those sample whose sample size is less than 30 is known as simple small sample, but that 30 is compared to the 100. Out of 100, if you have 30 samples, sample size, then you should use t-test or like that. And more than 30, then you can go with the z-test.
Okay.
Because approximately you will get near about same result from z-test also.
Oh, okay, sir.
Okay. Okay, I'll show you another example. Uh, there are 11 students. The students where their marks of English and maths are there. Okay, 11 students whose English and maths marks are there. Remember, this is not pair test, but this is independent sample t-test. Yes, the students are same, but they are getting different marks in English and mathematics. Here, our concentration is not on the only the students, their performance in the subject matter. Are you getting my point?
Yes, sir.
In the previous example, when I have copied, when I was copied from Excel, in that example, that also we have drag A and drag B, right? And that drag A and drag B are applied to different persons. But in this case, the drag are applied to same persons. Or say marks of English and maths for same persons. Then how we will go or how we will do analyze?
So then I think the grouping variable will be the subject. So it can either be
Yeah,
group 1
definitely.
marks.
The grouping variable will be the subject so
Yeah.
that we can draw some conclusion. Okay, I'll show another example. Also an example of pair t-test. There are two new variable. One is called after SBP, means after getting some kind of drug, we are collecting data from the respondent, and after getting the drug, we are collecting from the respondent and diastolic blood pressure. One is for systolic blood pressure, and the other one is called for diastolic blood pressure. After getting drug, we have initial systolic blood pressure. We have uh, after medication systolic blood pressure, we have initial diastolic blood pressure. We have uh, after getting the drug, diastolic blood pressure. Then go to the analyze, compare means, then paired sample t-test. Repeating the point, go to the analyze, compare means, then paired sample t-test. Click on this. Okay, this kind of table will appear. First, systolic blood pressure entered for variable 1. Compare it with after SBP, because initial systolic blood pressure and final systolic blood pressure. Okay, then diastolic blood pressure, initial diastolic blood pressure and final diastolic blood pressure, and press OK. This is the group statistic. Sorry, yes, this one. Since we have used two pair t-test here, so for pair 1, pair 2. Instead of doing this, you can do only for one sample, one test also. Like I'll show you. Instead of doing actually again and again the same thing, I'm doing the thing at the same place, same time. Systolic blood pressure initial and after. Okay. Okay, this one. Pair 1, systolic blood pressure, diastolic blood pressure. These are the descriptive statistics. The first table shows the descriptive statistics. Then the last table. This is the results of pair t-test. Again, here the result of t-value is 0.755492 with 0.451 or 0.451 p-value. Since p-value is greater than what? Since p-value is greater than 0.05, we accept the null hypothesis. In case of pair t-test, what should our null hypothesis? Can anyone say? For pair t-test, null hypothesis should be what?
So that the mean is going to be the same before and after the medication.
Yeah, I'll show you. Yes. Mean BP level before treatment is same as mean BP level after treatment. For our case, it is like mean SBP after treatment, before treatment equal to mean SBP after, right? And we are what? Accepting this null hypothesis, which means what? For general person or general laymen who don't know statistics, for them, how can we interpret that result? We are accepting the null hypothesis.
So basically, that the treatment is not
Has no effect,
has no effect.
right?
Yeah.
The treatment, or say the drug has no effect on the systolic blood pressure. That's why we are getting this kind of result. That's all. Are you getting my point?
Yes, sir.
So the next last one is ANOVA. I already told you that when we can use ANOVA, whenever they will have more than 2 samples, then only we can use ANOVA. For 2 samples, for 1 sample, we go with t-test, but whenever we will have more than 2 samples, we have to go with ANOVA, or say F-test. Go to the analyze, then compare means, then one-way ANOVA. Click on that. Now, I want to check the mean systolic blood pressure with the what? type of work. Why? Because why? Type of work, there are three categories: sedentary, active work, heavy work. Okay, since there are three categories, we are using this for the example. First, systolic blood pressure, then type of work. Press OK, and we will get some results. Yes, this one, ANOVA. Between groups, sum of square is this. When you are doing ANOVA, you must have to put this table in your dissertation or paper, right? So that people can see what you are doing. But in case of t-test, all the things are not necessary to put in the your manuscript. Here, between groups, sum of squares are given. Within groups, sum of squares are given. Then degrees of freedom are given, and then finally the F value and significant value. After writing, after putting this table in your manuscript, just write about the F value, what you are getting, and then the significant value, what it is. In this case, as the significant value is less than 0.05, then we can conclude that the mean systolic blood pressure for sedentary, active, and hard work respondents are more or less same. Okay, in case of ANOVA, the null hypothesis is like mean SBP for sedentary is equal to mean SBP active, mean SBP for hard work. Okay, these are three categories, and mean value is more or less same. Okay, and in alternative hypothesis, it is like not equal to. Since we are rejecting the null hypothesis, our conclusion is like the mean SBP of the work category is not same. Again, if there may be a query arise in your mind, whose category is different? Whether all the mean SBP, whether all these three categories are different from all, or only one or two category is different from equal. In that case, go to analyze, compare means, repeat the same procedure, one-way ANOVA, systolic blood pressure, then type of work. Okay, there is an option post hoc. There is an option post hoc in the right side after the contrast. Click on that. Click the two case and Duncans. These are two different testing procedure, and generally mostly use testing procedure to use for post hoc or multiple comparison analysis. Click on these two and then click continue, then press OK. Now come to the output page. Now see what are the difference. This is for today's HSD test. For systolic blood pressure, we are doing for sedentary, active, and heavy. There are 3 categories. Type of work: sedentary. Sedentary and active, it is not significant. If we see the original figure, as a whole, the 3 category shows significant value, but when we go to the post hoc analysis, we see that sedentary and active has no significant difference. Okay, but sedentary and heavy also, there is no significant difference. All these significant value are showing 0.05. Means initially we get okay, don't compare with that. Okay, we are taking another variable actually. Okay, see, okay, this one. Actually, I am using 2 or 3, or I am working with 2 or 3 SPSS files. So something had I choose some wrong file. This was the original analysis. As a whole, the 3 groups have some effect or some different from 3, since it is coming as significant. But when we use 2-case HSD for post-hoc analysis, we see that sedentary and active have significant difference. Sedentary and hard work have significant difference, but active and heavy work showing 0.1. Are you getting the point? Active and heavy work and active, both are same. Active and heavy work showing non-significant value. Initially, it was significant when we are doing that analysis for the group as a whole. But when we want to check whether all the 3 category have impact or all the 3 category are different from all or not, that only we came to the knowledge that active and heavy work do not have that significant result. So sometimes somewhere it is needed to use those post hoc analysis.
So could you please explain again post-hoc analysis? When to
Okay.
use?
How to use?
When to use and why we have to use post-hoc?
Okay. See, first of all, I am repeating the things. Go to the analyze, go to the compare means, then one way ANOVA. Okay. Click on that. Dependent list mean systolic blood pressure. I want to check whether the mean systolic blood pressure is same for all those respondents having depending on type of works. Or I want to check whether type of work has some impact on mean systolic blood pressure or not. Okay. If we if we click as OK, we are getting that ANOVA table, which give me the result that yes, they have some impact or they are not same. Okay, which means the H note is not true. Okay, but we want to check what category or which category is responsible for this significant value, whether the all three categories are responsible for this significant value or there are only one or two category is responsible for this significant value. Means if we see from the hypothesis whether mean, we are getting this, right? Mean SBP of this is not equal to mean SBP of active, mean SBP of this. Mean SBP of sedentary is not equal to mean SBP of active, is not equal to mean SBP of hardware respondent. Now we want to check whether this is true, whether only this is true, whether this and this is not equal, right? We'll get three conditions. Either sedentary is non-equal to active and not equal to hard, heavy or hard work, or sedentary is not equal to active, sedentary is not equal to heavy, or sedentary is not equal to, active is not equal to heavy. As a whole, the analysis will give you only this result. The sum of them or one of them is not true, not equal. If we say whether this condition is true, whether this condition is satisfied, whether this condition is satisfied, or whether this, if we want more knowledge about the data set, or if we want to check these three conditions, then we have to go for the post hoc analysis. Now, if we go for the post hoc analysis, click the post hoc, after the contrast, the second point from the beginning, click to case and done comes, then continue and then press OK. Now, in the first table, you are getting that it is significant, which means this is false, this is true, but the second one, this one shows that the null hypothesis may be accepted, rejected, and alternative hypothesis is accepted. Okay, but this shows that no, this value and this value both are coming for active and heavy work is not significant, which means you are getting this result. This is happening for this and this, not for this. I'm showing you in a, your results is satisfied for sedentary not equal to active not equal to heavy, right? But after post hoc, you are getting that sedentary is not equal to active, sedentary is not equal to heavy, but active might be equal to heavy. Now, is it clear?
Yes, sir.
Okay, fine. So at the last, we'll see how to do chi-square analysis to check the attributes.
So I want to ask you one thing over here. Like over here, since there were three categories, we chose ANOVA.
Yes.
Similarly, in that previous example that you had given, where we were comparing the mean of the marks of the students for science and maths,
Yes.
suppose there would have been a third subject, sir, English. In that case, we would again use one way ANOVA.
Yes, I will show you one example. Yes, this one. This one.
Yeah, it's drug A, drug B, drug
This
C.
one,
Yes, sir,
drug
the
A
same
and
thing.
drug B. If there is drug C also there,
Then we'll again use one way ANOVA.
then we have to use one-way ANOVA. I'm showing you
Okay.
for drug A and drug B. If we have to compare with drug A and drug B, then it's okay to do it t-test. But if we have drug C also, then we have to go through the ANOVA. For example, this one. Okay. So from here we have to. I'll show you. Copy these things. Put here, and then one another thing should be there. Drug C, add, okay, and then drug C, okay. Now, if you want to do independent t-test, then see the grouping variable. Here only you have two categories, but originally your variable is of three categories, right? So you can't use t-test here. Instead of doing t-test, you have to go for one-way ANOVA. Compare means one-way ANOVA. Systolic blood pressure is dependent, drug S factor, and then press OK. This one. Now, is it clear?
Yes, sir.
Okay.
Sir, I have a question.
Mhm.
If we are going to measure the effect of one treatment in various intervals of time,
Mhm.
then will this ANOVA analysis will help?
Yeah, definitely. But depending, you are
Such as
using.
I'm going for follow-up research that
Mhm.
I have applied some treatment in a group,
Mhm.
and I want to know the effectiveness of treatment over the period of time.
Mhm.
So with the same test score, we will measure the effectiveness in various intervals of time to check the.
Yes, I'm getting your point.
Yeah.
See, if you are collecting data for only 2 times,
Yeah.
then you can use time t-test.
Okay.
Okay, but if you are collecting data for 3 or more times,
Yes.
say you are there is two groups, one is case and one is control group. Okay, in the case group you are entering some drug to the patient, and then collect the data for first day. Repeatedly you are collecting data for second day, third day, fourth day also.
Yeah.
And now after the 5th day you want to check whether there is some kind of improvement have been happening or not. In
Yes.
that case you have to use ANOVA, because if you are if you want to analyze the impact on the second day, then you can use t-test because you have data for first day and second day. But you are deciding to check the result on 5th day after collecting 5th data set, after collecting 5 repeated measure.
Yes. Sir.
It is greater than 2, so you have to go through the F test.
Okay. ANOVA with
ANOVA, yes, ANOVA.
Okay, ANOVA with the Duncan's
And
Yeah,
yes,
because
after that, you have to use post hoc analysis so that you can check whether the drug or the anything you are entering to the patient
yeah.
has started impacting on from day third or from day four,
Okay.
from which time period it is starting to impact.
Okay.
That result can be done or checked from the post hoc analysis.
Okay, sir. Thank you, sir.
Okay, fine. So at the last part, I'll show you the cross-step for chi-square test. Click on Analyze, then Descriptive Statistics, then cross-steps. Click on this. Now, you want to check whether consumption of extra salt have some impact or consumption of extra salt is associated with blood pressure. Okay. There is a variable hypertension. Okay. There is a variable or say a column like hypertension. How we calculate this hypertension? By recoding or by computing. I think you have learned about computing and recoding types things which are very much essential in SPSS. Okay, since see mean HPP SPP is 114 and DBP is 86, so it is not hypertensive. I will show one case, this one. Here the SBP is 200 and DBP is 110. So why we are assigning this respondent as hypertensive patient. Okay. Now we want to check whether there is any kind of association exist in between hypertension and salt, taking of extra salt. Here it's not should be like there is some association. There is some association exist with in between hypertension and extra salt consumption. Extra salt consumption. This is the hypothesis. We want to check, is there any association? My research question will be, is there any association exist between hypertension and extra salt consumption? Depending upon my research question, I have constructed a null hypothesis like there is some association exist in between hypertension and extra salt consumption. Or we say whether extra salt consumption have some impact or not on hypertension. In that case, go to the analyze, go to the descriptive statistics, go to the cross-step. First go to the analyze, then descriptive statistic, then cross-step. Click on that. Click mean SBP in the row, and then extra salt in the column. Then click on the statistics, the second top option. Click on the chi-square, and then click continue, and then press OK. Now we see what the results says. Okay, this one, the first one, Pearson chi-square. The value of the chi-square is 245.576. Degrees of freedom is this, and significant level, asymptotic significance, two-sided. Two-sided means two-sided null hypothesis. Alternative hypothesis is two-sided, and the p-value is 0.873, which means we accept the null hypothesis. What is the null hypothesis? Sorry, there is no association. Sorry, there is no association exists in between hypertension and extrasol. An alternative hypothesis will be there is some association exists. So again, I will show you analyze, compare, descriptive statistics, Kulldep, mean, extrasol consumption, and there are many things which you can use in a chi-square test. Depending upon your needs, you can construct some tables. Statistics, I will use only chi-square. You can see the correlation also, and these are the things. Then cells, if you need the observed and expected frequency, then also you can. And then formats, cluster, suppress tables are there. Okay. Again, if you want to check, sorry, I have put some wrong example actually. Go to the descriptive statistics, Kulldep. I want to show you the hypertension. Again, remember we use the chi-square test for association or attributes or only the categorical variables. I have showed you the wrong example. Sorry for that. In row, we put hypertension, and in column, we put extrasol. I want to see some bar chart and suppress table. Okay, press OK. Okay. So this is the result. This is the descriptive statistics, and you need only the first row here. Pearson chi-square value is 0.352, 1 degrees of freedom, and significant value is 0.553, which means we accept the null hypothesis, means there is no difference on the consumption of extrasol on hypertension. And this is the bar chart. Bar chart where this is yes, but have hypertension. No, sorry, hypertension yes, but blue refers yes, red refers no. X-axis refers hypertension and y-axis refers count, which means this is yes. This first two bar shows the hypertensive patient, and the second two bar shows non-hypertensive patient. Out of these hypertensive patients, blue are consuming extrasol, red are not consuming extrasol. In no hypertension, blue line shows consumption of extrasol, and red bar shows not consumption of extrasol. Again, depending upon your needs, you will have some extra tables, like for exact it is okay. Statistics, you are chi-square and use also correlation, then continue. Well, it is okay. Then yes, this is not needed. Bootstrap is not needed, and then just press OK, and these are the things. So these are the symmetric measure for correlations. Pearson R correlation are calculated here, but you just consider the Spearman correlation here because the data are not in series or not in discrete order or not in scaling position because your data are in categorical variable. So you use only the Spearman correlation here. Okay. That's all from my presentation part. I'm seeing some questions. Yes, how we can decide which test is best or suitable for our research. Actually, these things can be, this goal can be met actually by using your previous literature review, because first you have to draw some research question by seeing the research gap, and then to meet with that, to get the answer of that research question, you have to construct some hypothesis. Okay, but after constructing the hypothesis, you have to have some data set, right? After that,
Sir has lost his connection, probably.